So before we go into the three-part purpose, back to the virus. So when I hear you talk about the virus and the different virus and that's inside of us already, how do we contract another virus?
Right. If it's already in us.
Yes. Well, you have 380 trillion viruses that are viruses that are there. You may have remnants of things. All of us carry little pieces of viruses. The issue is the abundance of them, the amount of them. Look, there are some viruses that are not in you that are outside that will come to you. Evolution is constantly taking place. Nature is constantly changing. Viruses are being created. It's like, just like people come and people go. Viruses come and viruses go, right? Life is not just as human beings. It's quite extraordinary, right? So how do you contract a virus? Well, if you look out, you ever see light and you see those little dust particles? Well, those are viruses hanging out. Those are bacteria. They're all around us. So how do we contract them? Well, the reality is we're interacting with viruses and bacteria and pathogens and fungus every moment, all the time. I mean, I can't, probably every millisecond we're interacting with them. The important thing to understand, it's not like we are here and the virus is over there.
Right.
I also want to let people know that we invite everyone to come to an orientation. Every Thursdays at 11 a.m. and 8 p.m. I host an open house. Lots of great people show up. You have a lot of chance to meet people from all over the world. Every Thursdays we do a open house. Anyone's invited. You can just RSVP at vashiva.com/orientation. We have people all over the world come in and we discuss how we actually build a movement to end the nonsense that's going on. If you think, oh my God, the world's going to hell, I'm so confused, you'll get very inspired at seeing there's a lot of people who are coming to our movement for truth, freedom, and health. Please join us there. All these things are everywhere. They're within us. They're outside of us. It's like it being a goldfish in a bowl or a fish. The water in that bowl is all sorts of viruses and bacteria that we interact with. We're living among them. So the real question comes down. Does that make sense?
It makes sense.
Yeah.
So we're living in an amazing, beautiful jungle of viruses, bacteria, and everyone's trying to survive. And some of them make it and some of them don't, right? It's the struggle of life. All of this is occurring at the grand scale and all the way down at the molecular scale. And this is life.
Well, what make this virus, what make the coronavirus so different than all of the other viruses that lives in us and that surrounds us every day?
Yeah, it's a good question. And I think that's the fundamental question. What makes this virus different? And why has there been so much focus on this virus? Well, let's talk about this. So remember, flu season comes typically around September to March, right? In the United States. Well, at that time, people are more susceptible to get colds and flus, etc. Why? Well, one of the reasons is that we're in an environment where we don't have as much sun, right? We're in an environment where we have less vitamin D. So this is very, very important that people need to understand when we talk about the fact is vitamin D is an antimicrobial. It's something that actually can take out bacteria, viruses, fungi, etc., and parasites. Vitamin D is extremely important. We forget that we live on a thing called the earth, and there's another very big thing called the sun, about 6,000 degrees. Without the sun, nothing exists. That sun provides us something very, very important called UV radiation, which hits our skins, and particularly, people like us have, brown, darker skin. We need more of it because it's harder for the UVB radiation to get through. So we actually need more vitamin D during the winter. So because it's harder for us to get it. But in general, all people need a certain amount of vitamin D. Now, typically, if you're outside before the winter comes, you get a lot of that, right? And you store it up, you get enough vitamin D. But that vitamin D is essential to take on the bacteria and to take on viruses because it makes sure that the ones that are not appropriate for your body get taken out. So how do we, so in the time, around the winter time, there's lots of different flu viruses. The coronavirus broadly refers to a big class of viruses, a big class of flu viruses. Does that make sense? Coronavirus, there's a lot of viruses that fall under coronavirus. However, now what are these viruses? A virus literally is its own life form. Many times think about it, it's got a little ball, okay? Inside that ball is what's called ribonucleic acids. Essentially, not DNA, sort of half of DNA, but it's essentially DNA-like structures. And around that is a ball of proteins, and then sometimes they have spikes on it, okay? Right. So it's basically a ball, and I'm sort of simplifying this for the audience, but basically it's a container which contains ribonucleic acids. In the case of the coronavirus, there was a class of coronavirus which gave acute respiratory disorders, okay, acute respiratory issues. One of them was SARS, remember, about several years ago.
Yes.
Caused acute respiratory function. Another one was MERS, the Middle East Respiratory Syndrome virus. This is a class of that which people believe causes acute respiratory dysfunction, all right? The difference between this virus and the SARS is, remember I told you inside that ball is these nucleotide base sequences. Typically, they're about 30,000 nucleotides long. And think about a ladder, with 30 different rungs to it. That's the nucleotide base sequence. A portion of that, around 1,500 of those base sequences, are different than SARS. And the thesis was that this virus is a little more, can cause more death than the SARS virus. Two parts to it. This virus also has a higher infectivity rate. So what do I mean by that? So think about your cell as this big ball, talking about how does a virus get in. Now, if the cell has certain protection, the virus is never even going to be able to come there, and we'll talk about that. But if you have a cell, and remember those old lunar modules? Remember when Apollo 13 landed on the Mars? I mean, or landed on the moon? Remember what I'm talking about? Those little landers? Yeah. So a virus literally lands on your cell surface, and it attempts to get into your cell and uses your cell's factory to try to replicate itself. It's like a crook. He comes and takes the machinery of your cell, and it tries to replicate itself. And then it leaves with more particles. And then they go replicate the next cell, the next cell. The key in all of this is the amount of replication that takes place. I mean, if you have one virus particle, no big deal. We probably have all one of something in us, okay? The issue is your body is able to detect it and keep it under control in the normal case of the immune system. But it's like, you don't clean your house enough, right? So you get all sorts of mess occurring everywhere. And that's what occurs here. If you don't take out these pathogens right away, or your body doesn't naturally treat it, they grow and they grow and they grow and they replicate.